The next thing that we're going to need to do is get these warp points working. Because as you can see, we just get caught. And the reason why is because there's no more nodes to the left. So it's basically saying we can't go that way. So what we're going to do is expand our nodes container, and we're going to create an empty container called regular nodes. And we're going to take all of our nodes so far and drop them into our regular nodes folder. So now you should be able to minimize it. It should look like that. So then we're going to create a child called warp nodes right and warp nodes left. And now we want to just zoom in, and we're going to grab this right here, this node, and we want to drag it in to our warp nodes right. And we want to do that for each of these nodes on the side. And only the final node is technically going to be our warp, but we want to know which nodes are the sides, because once the ghost gets into this area, they're going to slow down. Okay, so I have the right nodes done. Now I'm going to move on to the left. I just realized now you can right click and click cut. Can I paste as child? Wow. That's wild. We're just going to do that real quick instead. The more you know. Paste as child. For some reason I thought it didn't work like that in this specifically, but I was wrong. And paste as child. Okay, so now if we highlight warp nodes left, you should see the left nodes, and warp nodes right, you should see the right nodes. Now there isn't actually enough. So what we're going to do is go to our last warp node on the right, and we're going to copy it. We're just going to move one over a little bit. It doesn't matter if it's exact. It doesn't even matter if it looks a little bit off, because keep in mind, the warp nodes don't have pellets eventually, so nobody's going to see them anyway. And we're going to add another one. We want to add the next one to be off. Okay. We might actually even want... Yeah, that should be fine for now. So then we're going to do the exact same thing with our left nodes. Copy that, move it over a little bit. As long as it's far enough or close enough where it detects it that you can move in that direction, you're fine. Okay, so if I hit play, will it be able to detect that we can move right here? Yes, it is. So that's great. We're going to move the one on the right over a little bit more. And then make sure if that can go left. And it can. Okay, so now what we're going to do is actually make it so that if you touch this node, you warp to the left and vice versa. Okay, let's go back to our movement controller. And right here, we're going to add an if statement. We don't want to determine the next node if we're in a warp node. We want to immediately warp. So actually, we need to go to our node controller first and type in public bool is warp right node equal to false, and then public bool is warp left node equal to false. So then under the right warp node, we're going to set is warp right node to true. Let's just rename this to right warp Same with this, left warp, and we're going to set is warp left node to true. And then we need to be able to access the game object for the left and right warp nodes. But keep in mind, the left warp node doesn't have access to the right warp node because they're not beside each other, so the ray cast won't hit. So what we're going to do is create a game manager. And a game manager is something that most games have that keeps track of global things, such as like the score or how many lives you have, etc. And a game manager is literally just a game object called game manager with a script called game manager. It's nothing special. It's nothing any different than the scripts we've had so far, but this is going to be used to keep track of global things that a bunch of different game objects are going to need access to, such as public game object left warp node and public game object right warp node. So now what we can do is go back to our game manager and then drag our right warp into our right warp node and our left warp into our into our left warp node. And now in our movement controller, we can just reference the game manager by typing in public game manager. And you might be wondering, why are you typing in the word game manager twice? The first time is the class name. So you can see game manager is here. And then the second thing can be called literally whatever we want, but it makes sense to refer to it as the game manager. So this is whatever you refer to. So if I typed in like test, I could do like test dot left warp node, and that would work. But this doesn't really make any sense. So we're just going to name it game manager with a lowercase g. Hopefully that's not too confusing. Okay, so we're going to say if current node controller dot is warp left node. So let's just add a comment. If we reached the center of the left warp, warp to the right warp, we'll set current node equal to game manager dot right warp node. And then we're going to set our direction manually to be left because we want to go opposite of right. And we're going to set last moving direction to equal left as well. And then we're going to say we're going to immediately warp our position. So transform.position equals current node.transform.position. So this is not going to move towards, it's just going to immediately snap it to that position. Then we're going to say else if current node controller dot is warp right node. We're going to basically do the exact same thing, except for we're going to warp to our left warp node. We're going to set our direction to be right, our last moving direction to be right, and our transform.position to be current node.transform.position. Else, if we aren't at a warp node, that's when we're going to want to do the rest of this stuff. So if we reach the center of the left warp node, warp to the right warp. If we reached the center of the right warp, warp to the left warp. Forgot a semicolon. Otherwise, find the next node we are going to be moving towards. Now, there is going to be a bug here. Basically, it is going to infinitely warp us back and forth because we're going to warp to the right node, and then it's going to say, okay, we're in the center of the right node, warp to the left node. Oh, we're in the center of the left node, warp to the right node. And actually, I don't necessarily need to show you, but if you want to check it out right now, you can go into your game, and you'll notice you will be warping back and forth. So what we're going to do is have a public bool can warp equal to true. And we're just going to say if we're in the left warp node and we can warp. Same with down here, and can warp. So if we warp, we're going to immediately set can warp to equal false. And then we need to set it back to true when we're allowed to warp again. So when are we allowed to warp again? Well, it would be when we leave the center of the node, right? We warp, we leave, we can instantly warp back if we want to. And luckily, we already have something to figure that out. So this if statement is saying, if we reach the center of the node, well, we can just do an else. We aren't in the center of a node. So we can safely set can warp back to true here. And now let's run the game. Okay, so I'm getting this null reference exception, object reference not sent to an instance of an object. So it's game manager. So even though we declared our game manager up top, we didn't set it to the actual game manager. We still need to find that. So this is really easy. We're just going to do game manager equals game object dot find game manager dot get component game manager. So this is going to grab our game manager object and then grab the script from it and set it to this local variable. We're also going to change this from void start to void awake. And I want to do that in the player controller as well. And awake happens before anything runs at all. Start happens as soon as the game loads. We want to run and set all these things before the game even loads. So anything that we're doing in start, let's just do it in awake. Okay, so now let's try reloading the game once again. Unfortunately, my Unity is a little bit laggy right now, and the reason why is because I have my second project open on the other monitor. So it's trying to run two versions of Unity at the exact same time. So hopefully yours is running just a little bit faster than this. Okay. And our warps work, and we can warp instantly if we want to. So that's really cool. The next thing we're going to want to do is start actually animating Pac-Man and making him change his sprite direction depending on which direction he's going into. Okay, so let's start animating Pac-Man. So we're going to click Pac-Man sprite, and we're going to go to our animation tab, and we're going to click create. And then we want to go to our animations folder and create a folder called Pac-Man. And then we are going to have a moving left animation. And we're going to take our project, and we're going to just bring it up to here so that we can see our game, our project, and our animator. Then all we need to do is go to our sprites, find our Pac-Man left, and we're going to set it at 0, and then we're going to set closed at 6, and these are milliseconds, and then we're going to set it our left back to 12. So we have left, middle, left. And now if we click play, you can see it's actually just playing the animation. So that's already done. We're going to create a new clip called moving up. And then we're going to do the exact same thing. We're going to put Pac-Man up 0, Pac-Man closed 6, Pac-Man up 12, and then click play. And as you can see, we have Pac-Man going up. Now we're going to click our animator, and this is going to have our animation nodes. Finally, we're going to create another new clip called start anim. Because we don't always want Pac-Man to be moving when he first starts, we're going to want him to just be stagnant. Okay, so now if we click our animator, we're going to see all these things. So our entry is what we started. So we're going to want to start at our start anim. So we're going to say set as layer default state. And then any state just means at any time we can move into one of these positions, which is what we're going to want to do. At any time we want to be able to move left, and at any time we want to be able to move up. And we're going to select this arrow, and we're going to click this plus right here, and we're going to be able to add basically a condition. that's going to say if this equals this, then transition to this animation. So we're going to create an integer called direction, and it's going to be set by default to 0. And our condition for moving left is if direction equals 0, and our condition for moving up is if direction equals 1. Now we're going to add another condition called moving. And we only want to transition to both of these if moving equals true. We also want to transition back to our start anim if moving equals false. So if moving equals false, we just stand there and don't move. If moving equals true, we do one of these two things. This is direction equals 0, and this is direction equals 1. We're going to be setting all of these things in our code. Now, there's a few things that we're going to want to do. So we're going to go arrow by arrow. Click the top arrow. You're going to want to click has exit time, set exit time to 0. On click has exit time. On click fixed duration, set transition to duration to 0. On check can transition to self. And we're going to do that for all of these. Now, if we load the game, let's see what happens. I believe moving should be default set to off, and we should be continuously running our start anim. But I could be wrong. Okay, so yeah, our start anim is running. If we set moving to true, it's going to start calling our left anim, which right now is blinking. I'm not sure why that's happening. So I'm going to have to look into that, and I will be right back. All right, so I found the issue, but then I recorded myself doing it, but for some reason my mic wasn't working. So I'm just going to show you guys what I did in order to fix the blinking problem. So under player, we want to make sure our Z is set to 0. What was actually happening wasn't that we were blinking, but we were going in, behind, and then to the front of the background. So we were just popping through the background as we were animating. And then go to Pac-Man sprite and set order and layer to be 1. So it will just be a little bit ahead of everything else, which is by default 0. Then that should actually completely stop the blinking problem. So the next thing we need to do, if you hit play right now, it should be animating fine, but it won't be animating as you move. So that's the next thing we want to work on. So again, I already coded this, but it's not too much. The first thing we want to reference up top is our animator and our sprite renderer. So we want to be able to access both of those things. Then in our awake function, we're going to say animator equals get component and children animator, and sprite equals get component and children sprite renderer. Now before we use get component, this time we have to use get component and children. And the reason why is pretty obvious. So our player controller is attached to our player object, but the sprite renderer and the animator are on our player's child Pac-Man sprite. So we just call get component and children. It's important to note that if we had multiple animators and multiple children, this would not work, but because we only have one, it works just fine. Then, at the top of our update above the if statement, we set bool moving to true. When we call animator.setBool, we can also call like setInt or whatever, but because moving is a boolean, we call setBool, and we access it through the string moving, and then we set it to true. So we're just saying we are moving. And then we're going to go below this if statement, and this is new stuff that I want you guys to type in. So basically, if we go left or right, we're going to set our direction to 0, and if we go up and down, we're going to set our direction to 1. However, we only have two animations. We have left and we have up. So if we go right, we're just going to flip Pac-Man's sprite horizontally, and if we go down, we're going to flip it vertically. So for reference, if I click Pac-Man sprite and click flip X, this is going to basically be what we're doing in our code. Alright, so my power just went out, so it might be a little dark in the webcam, but right before I test this out, I just want to say that I reloaded Unity, and I noticed that the background is ahead of all the pellets. Let's set our background's order and layer to -1 to solve that problem. And now, if we click play, wait for the game to load, ideally, Pac-Man's movement should be completely done. So mine is lagging a little bit, but it won't actually look like that in the game build, and it probably won't look like that on yours either. My laptop's no longer connected to power because my power went out, so everything slowed down even more. But yeah, as you can see, Pac-Man's movement is working really well.